so in this clip we're going to be talking about finding intercepts. And in order to illustrate this, let's just take the straight line, for example, because this is something everybody gets taught in Algebra 1. So where it's going to cross each of the axes here, and this is our y and our x, that's going to be our intercept. So we know that y equals mx plus b is the equation for a straight line, and we have a particular name for this. We would say that the straight line is a linear case. So what we can do in order to find our intercepts is we can actually take the equation of our axes and we can set it up as a system of equations, and then we can solve by substitution. So let's do that. So we have y equals 0 for one of them, and y equals mx plus b. And for the other one, we're going to use x equals 0 and y equals mx plus b, and we're going to see what we come up with. So making the substitution, we're going to substitute 0 in for y here equals mx plus b. So we can say, putting the b over here, negative b equals mx divided by m, and we can say that x is going to be at negative b over m, or in other words, we're going to have our x-intercept at negative b over m comma 0. And for trying to solve for the y-intercept, then we're going to plug in the 0 for x, so y equals m times 0 plus b, or the m times 0 is 0, that goes away, so y equals b. So we're going to have a y-intercept at 0 comma b. So these points can be described by 0 comma b and negative b over m comma 0. And okay, so let's go ahead and write out what these different things mean in the equation. So you were probably taught that m equals the slope, which is defined as the rise over run, which would be the change in y over change in x in a particular interval. And okay, so b is what we would call our y-intercept, and x is, it's a variable, but it's our input, and y is the other variable, or well, it's our output, but we would say that x is the independent variable and y is the dependent variable because it depends on what x is. So, okay, so this is pretty useful for when we have like a slope that's not infinite or anything like that, but what happens when we do have like a 0 slope or an infinite slope? There's a few cases we also need to take into consideration. So let's say that we have some kind of x equals c, for example, like this, and Okay, so let's say we have x equals c, but x does not equal 0, but c does not equal 0, where we're using c as the constant. Then if we're going to talk about what is the slope of this, well, we could describe that as m1. Well, our rise is basically infinite for a time interval for 0 run. So we have essentially an infinite slope, but also if we're going to compare the equation of the y-axis to that, then also we're going to have m equals infinity over 0 equals infinity. Call that m2, and because m1 equals m2, then we know that this is parallel, meaning that these two lines here, the x equals c and the y-axis, have no chance to ever cross. So we know that in this situation, we are going to have some kind of x-intercept here being at c comma 0. So in this case, x-intercept at c comma 0. But as far as having a y-intercept, we have none. So what if now we have x equals c, but c equals 0, or in other words, we're talking about the equation x equals 0. Well, in that case, if we still make this comparison, the equation of the y-axis is going to be x equals 0, or in other words, they're the same equation, and whenever that happens, then you have an infinite amount of intercepts. So, but we are still going to have the x-intercept here, just at 0 comma 0. So x-intercept at 0 comma 0, and the y-intercept, we're going to have an infinite amount of those cases. So now what if we're going to talk about y equals some kind of constant, y equals c. So let's say we need to discuss the case of y equals c, but c does not equal 0. Then the x-axis, we're going to have, so let's compare these slopes. So m1 in this case would equal, we have 0 rise over however infinite amount of run you want to call it. So it's going to be 0, and m2, we get the same thing, or 0. So basically, m1 equals m2, or these are going to be parallel. So we can say with confidence that it's never going to touch the x-axis. So x-intercept, we have none, and the y-intercept is going to be taking place at some 0 comma c. Okay, so now let's think about the case for y equals c, but c equals 0. Well, in other words, we would have y equals 0, but the equation of the x-axis is y equals 0. So in other words, these are the same equations here, and they're going to have an infinite amount of x-intercepts. So x-intercept, we're going to have an infinite amount in this case, and y-intercept is going to be taking place at, once again, the origin 0, 0. So notice here how in any possible case that you can think of, it's not possible to construct a straight line that does not have either at least one x-intercept and or one y-intercept. Because the line has to, by how we're constructing it, it's got to extend out in some kind of direction somehow. So basically, if you're doing your homework and your calculation led you to a conclusion, or so you think, that there's no intercepts, then you should check your calculation, because that's not possible. So yeah, these are the different possible cases you can have for intercepts, and we'll talk about more of how to solve systems of equations in another video or video series. But until next time, come back for the next video where Joe shows you how.